Simple random samples. Each member of the population is equally likely to be chosen, and each possible sample of the size you want is equally likely to be chosen. So we're going to take a closer look at a few different methods for simple random sampling. Some of them are going to be a little bit more prone to bias than others. So first one, stratified sampling. You have a population divided into groups with similar characteristics, and then a sample is randomly chosen from each of those groups. There's cluster sampling. You've got a population that's divided into convenient clusters, and the entire clusters are chosen at random as the sample. Systematic sampling is when you start with one member, you choose them at random, then you'd use a rule such as every third member of the population to select members of the sample. And now we're going to get into the two that have a very high risk of bias. Convenient sampling. You're choosing the easy subjects to get a hold of. In self-selected sampling, you're using volunteers. So now let's take a look at some examples. So starting with a randomly chosen ID number, every fifth student ID number was chosen, and that student was asked to fill out a survey. So in this example, this is going to be systematic sampling because you've randomly chosen one student, and then you've come up with some rule to go pick the remaining students that you're going to ask to fill out your survey. Chance of bias here is low. B, a retailer put feedback cards at the front of its store. They got responses from 22% of their customers. So self-selected sample, and here people are just, it's like who's gonna volunteer to respond. This has got a higher chance of being biased. A city wants to know what percent of people in the city own a dog or a cat. A city worker goes door to door in the neighborhood around City Hall to ask people about their pets. That right off the bat, you can probably tell it's very biased if you're only going in one area. So, you know, the amount of pets in the city can very much differ from anywhere else outside of such an urban area. So that is going to be a convenient sampling. They're just going somewhere where it's easy to get to, and high chance of bias. And now the triads. What sampling method is used in the following example? Is the method likely to be biased or not? So we've got two. A population is grouped according to age, and a random sample is chosen from each group. And then B, a number of hospitals around the country were randomly chosen. Within each hospital, all of the nurses were chosen. See if you can answer these on your own, pause the video, and then come on back to check your answers. So let's take a look at A. We've got a population is grouped according to age, and a random sample is chosen from each group. That is stratified. So you're going to be unbiased as long as the samples chosen from each group reflect the age group's percentage and of the population, and they have to otherwise be random. On B, a number of hospitals around the country were randomly chosen. Within each hospital, all of the nurses were chosen. So they're surveying nurses, but they're looking at the hospitals that the nurses were in. So this is cluster sampling. So each of these hospitals would be a cluster, and that would remain unbiased as long as those hospitals were just chosen at random. And now let's take a look at randomized experiments. So describe a design for a controlled experiment to test a new drug for treating the flu on mice. How does randomization apply to your design? So let's take a look. You will have an experimental group. That is going to be the group that receives the treatment. Then you'll have the control group. The control group does not receive the treatment. So what you're doing is you're applying a treatment to one group, not applying it to the other, and that way you can see what effect that treatment has. So let me give you a minute. You can finish reading that paragraph on the mice. And let's take a look at this study tip. Some experiments can have more than 2 groups, especially if you are testing multiple variables, and some experiments do not have a control group and just compare different treatments. So a control group isn't necessarily required. You could just be testing multiple different treatments to see which treatment is the best. And here's your try it. Design an experiment to test whether drinking coffee improves memory, and how will you choose the experimental and control groups? Okay, so we're going to need an experimental group and a control group. So the experimental group, we'll give them coffee. The control group will give them no coffee. And then what you can do is give them, each group, the exact same memory test and see how they perform.